So let's talk about superannuation. Now, essentially what superannuation is, it's a percentage of your income, your gross income, that your employer must contribute. That's not part of your income, I should say, but your employer must contribute to an account which then grows over the period of your lifetime due to things like compound interest. Now, it's important to note here that we're going to be making a lot of assumptions here that the interest rates are going to be constant throughout the entire investment, and you're not changing strategies because superannuation. You can ask your superannuation current agencies to invest your money into high risk strategies such as shares and things like that, which if you do that at the right time can have a lot of benefits to it. So it's not a stupid thing to do, but there is a lot of assumptions that we're going to be doing here during these calculations. We're going to simplify the calculations for the purpose of learning how super is sort of calculated in the first place, which then can be used to and applied in more complex calculations. So essentially, this is going to be broken up into sort of two parts. It's going to be looking at how much are you going to earn at the point of retirement, how much is going to be in your superannuation account in the point of retirement, but it's also going to be looking at, how do we actually draw an income from this superannuation, and how long is that income going to last for, or, if you need to last for a certain amount of time, what income can you draw from your superannuation in retirement? So that's essentially what we're going to be looking at here. So our learning intention is to show how regular income can be provided from savings. Those savings here being superannuation, and also looking at how to calculate the total amount our super is going to be during a period of investment, but also look at being able to calculate regular withdrawal amounts from superannuation. So let's get started. So on that first part, once again, superannuation is a long-term savings plan to help people save for retirement. Here in Australia, our superannuation contribution rate from our employer is set at 9.5%. That's what the employer has to contribute. That doesn't form part of your income, so it's over and above your income, but it's based on your gross income here. So that's something important to note. You can make voluntary contributions which do come out of your income over and above it, and it's a really wise thing to do, especially when you're younger. Because if you do it early, like the earlier that you make voluntary contributions, compound interest is an exponential growth. You'll have a much more significant growth from making regular contributions early. So that's something to consider. But here, in our example, Danny's currently 20 years old. He started full-time work as an electrician, where he'll earn $75,000 per annum. Danny's employer will make quarterly contributions to his superannuation fund. So the first thing we need to look at is how much will Danny's employer contribute each month. So the contribution, it's going to be 9.5% of the $75,000, and that will give you how much is going to be contributed per year. But we got to be very careful in these questions because it's not yearly contributions. In this case, it's quarterly contributions. So this 9.5%, if you're, working as one of my students, it's really an important value to know because it's something that I just assume that here in Australia, that it is currently 9.5%, at least at the time of recording this. So to calculate the employer, I'm going to switch colors here. So calculate the employer contribution. What this is a percentage of calculation. So we're going 9.5% of the $75,000. But like I indicated before, we've got to be very careful because this will give us our yearly contribution. We need to look at how often it's being contributed here, which is quarterly. So we need to divide this by 4 to get the quarterly contribution. If it was weekly, we'd need to divide by 52. If it was monthly, we'd need to divide it by 12, etc., etc. So that's just something to note here. Percentage of, we need to put the percentages of decimals, so 0.095 of just means multiply. So multiply that 75,000, all divided by 4 here, and that'll find us our employer contribution. So we'll just pop that into the calculator. Yep. So that will be $1,781.25. So that's the step one, is just working out what the contribution is going to be. If you're making voluntary contributions, you might need to change that percentage. So if you're making 2% voluntary contributions, this would become 11.5%. All right, so that's just something to be aware of. Now, Danny's superannuation fund returns 4% per annum, compounding half yearly. Find the amount of money in the fund when Danny retires at 60. Now, obviously, there's a whole range of assumptions that are being made here. The biggest assumption is that, well, two biggest assumptions is that the interest rate is going to remain stable at 4% right throughout. But probably the bigger assumption is the contributions are going to remain the same, which is very unlikely given things like inflation, things like that, which will change the wage, which will change the contribution. But like I said, we're just keeping it simple at the moment to learn how these calculations are performed so we can make these, estimates, I guess, and just keep those assumptions in mind when you're making these kinds of calculations. So to do this, we're going to use our graphics, our calculator here to perform this calculation, and we know to be the total number of times it's going to compound this time. So he's retiring at 60. He's currently 20, so it's going to be 40 years, and the account is compounding half yearly. So that's going to be 2. The interest rate of this account is 4%. The present value, we're starting at 0. Well, that's the assumption we're making here. The payments per term, that's the employee contribution. Now, this is going into the account, so it's going to be a negative value, and it's $1,781.25. The future value, that's what we're after, so we leave that as a question mark. Payments per year, now this is where you've got to be very, very careful here. So these contributions from the employer are occurring quarterly, so it's going to happen 4 times per year. That is going to be different in this situation compared to how often it's compounding. So it's compounding here half yearly. So that's just something to be very careful here. Sometimes they will be the same, sometimes they'll be different. So it's just something you've got to keep an eye out for. So the future value here is going to be, let's put this into the calculator. So solve that. So our future value is going to be approximately $216,252.65. So that's what the future value of our account's approximately going to be. You can see here that it's not necessarily a huge sum of money if you think about 40 years worth of inflation and think about how long you might need to live off of this in the future. So I'll give an example of it. So our next example, we're going to have a look at this. So Hope has just retired at the age of 65. So here what we're going to look at is Hope's got $1,250,000 saved up in a superannuation fund, and now she's going to roll this over into a pension fund to provide an income for her. Now, pension funds are special kinds of funds where they generally have generous interest rate returns. I mean, this is very generous at 3.8% compounded monthly, but they've generally got a reasonable interest rate, but it also allows you to withdraw money from these accounts while paying that interest rate. So they're a bit unique in their, sort of account that you've got here. So if Hope withdraws $7,200 per month to live on, how long is it going to take before our money runs out? And this is something that's going to be very, very important to consider. So essentially what we're going to do here is we're going to put this into our calculator. So the n is what we're calculating because this is going to be how long it's going to be. Now, n's obviously the number of times it's going to compound, but we'll get to that. The interest rate, now we're looking at the interest rate of her pension fund. And if this was, following a question from how she got to this amount, you've got to make sure you're grabbing the interest rate from the pension fund. So it's 3.8%. The present value, that's how much she's going to put into this account. So because she's putting it in at this point, it's going to be negative. So that's $1,250,000. Her payments per term is actually going to be positive here because she's withdrawing money from the bank each time. Now she's withdrawing here $7,200. So that's something to really get important, something that's really important to get your positives and negatives correct here. Your future value, well, this is going to be 0 because we're going to assume that we're doing this until the money runs out. And we're wanting to know how long is it going to take before there's nothing in the account. So now we're looking at the PY. So how often is she withdrawing this? She's withdrawing it monthly, so that'll be 12. And the CY, how often is it compounding? Also monthly. These won't always match, so just be very careful of that. So now we put these values into our calculator to look at how long will it take for her money to run out. So we're going to do an end calculation at 38%. That would have been a very generous interest rate. So 7,200. Like I said, the biggest thing here is probably getting your positives and negatives right. If you get them wrong, you're going to get a very different answer. So this is approximately 252.40. Now, very important here. You're looking at the compounding period, so this is months. So it's going to be approximately 252.40 months. And of course, if you need that in years, this question doesn't ask for it, so I wouldn't convert it if it doesn't need to be converted. But if you needed to, you would divide by 12 to get it into years here, or if you need it in a different unit, you would have to do the according calculation. So if we divide that by 12, it's around 21 years if we're interested in this. So if you think about that, she was currently 65 years old, 21 years approximately. We'll get her through to about 86. All right, and that's something to really consider, because what happens if she lives beyond 86? What's she going to live from? Where's her income going to come from? So, these are things that are really, really important to consider. So if Hope wants this money to last till she's 90, how much can she afford to actually withdraw? So this is something that she might be interested. She might go, to 86, I'm not really happy with that. Maybe I want to look till 90. So what this changes now is we know what N needs to be. So it's going to be the difference from 65 to 90, which in this case can be 25 years. But of course, this is compounding periods. So we're assuming this is the same account. So it's compounding monthly. The interest rate, we're assuming the same account, so it's 3.8%. The present value, once again, same account, so negative 1250000. The PMT though is what we're after now, and the future value, we're running it dry again. So the PY is still 12 and the CY is still 12. So now we're looking at PMT. 25 by 12. Yeah, that's the only thing that changed. So we're looking at approximately $6,460.71. And whilst it's not negative, we do need to include units here. So it is per, because it was compounding monthly, this is per month. Don't really need to write that little sentence afterwards. We're just indicating this is a monthly withdrawal that she's able to make. And you can really see quickly how much this reduces just to last that extra 4 years. So that's rather significant. So I guess with superannuation, there's two main types of the situations of the calculations that we need to make. It's when we're getting our super and calculating how much our employee contribution might be and how much super we might have at the end. But then we've also got to look at the other end of going, how do we use that super to withdraw money and make calculations associated with how long it's going to last, and also if we need to last a certain period of time, how much we can actually withdraw.